The problem on finding the Fourier series coefficients of a periodic signal which is shown in the figure. The question here is find the complex Fourier coefficient for the periodic waveform x of t as shown in the figure, and also we should draw its amplitude and phase spectrum. See, this is the periodic signal. 0 to 1 it is linearly increases, it looks like a ramp function. Then it suddenly it comes to 0. Again same pattern repeats 1 to 2 and 2 to 3. The fundamental period is t is equal to 1 second. Here this is 1 and its angular frequency is 2 pi by t, that is angular frequency is 2 pi. And what is x of t here? X of t is equal to t in the range 0 less than equal to t less than equal to 1. And same pattern repeats from 1 to 2, 2 to 3. Okay, it will be x of t plus 1. X of t is equal to t plus 1 in the range of 1 to 2, like that. Okay. Now in the fundamental period, x of t is equal to t. Now what is the Fourier series coefficient formula? X of k is equal to 1 by t integral of 0 to t x of t e to the power of minus jk omega into t into dt. X of k equals to t value is 1, that is 1 by 1 integral of 0 to 1. X of t is t, the fundamental range, e to the power of minus jk, omega is 2 pi into t into dt. Now I need to integrate this. This we have to apply the product rule. Already we know that integral of t into e to the power of at into dt. This is e to the power of at by a square into at minus 1. Now I'll show that how you are getting this answer. That is integral of t into e to the power of at into dt. Apply the product rule in the integration. That is t integral of e to the power of at with respect to dt minus integral of e to the power of at. Differentiation of t is 1 into dt. That is t e to the power integral of e to the power of at is e to the power of at by a minus integral of e to the power of at is e to the power of at by a square, because first integral value is e to the power of at by a, again integral is e to the power of at by a and a, it will become a square, that is e to the power of at by a square. That is a square is the LCM here, you can write, that is at e to the power of at, this is minus e to the power of at. Answer here it is e to the power of at is common, e to the power of at is common, at minus 1 all divided by a square. Okay. Similarly, let us compare this and this. T you have e to the power of at. Here in place of a we have minus j k 2 pi. Okay. Hence we can write x of k as, you can write x of k equals to x of k is equal to e to the power of at. E to the power of at value is e to the power of at by a square into we have at minus 1, where a is equal to minus j 2 pi k. A is equal to the power of minus j 2 pi k. When I substitute in that, you'll get x of k is equal to, substitute the limit 0 to 1 here, e to the power of minus j 2 pi k divided by minus j 2 pi k its whole square minus j 2 pi k into t minus 1. Substitute the limits 0 to 1. Okay, this will become x of k is equal to e to the power of minus j 2 pi k whole divided by minus its square, it will become plus, j square it will become minus sign, minus 2 pi k its whole square, and here you can take minus common, it will become 1 plus j 2 pi k into t. Apply the limit 0 to 1. Minus minus get cancelled. You get x of k is equal to e to the power of minus j 2 pi. So here t is there, at also t is there, 2 pi k into t divided by 2 pi k its whole square 1 plus j 2 pi k into t. Apply the limits 0 to 1. Then x of k is equal to, when upper limit is 1, e to the power of minus j 2 pi k divided by 2 pi k its whole square into 1 plus j 2 pi k, okay, minus e to the power of 0 value is 1. Here t is there, here also it will become 0 plus 1, it will become 1. 1 divided by 2 pi k its whole square. What is e to the power of minus j 2 pi k? For any value of k, its value is 1. E to the power of j 2 pi k value is 1. That is cos 2 pi k minus j sin 2 pi k. For any value of k, this part will become 1. Next, I can write x of k is equal to, LCM is 2 pi k whole square, pi k whole square. It's 1 plus j 2 pi k minus 1. 1 and minus 1 is get cancelled. Answer here it is, you have that is j 2 pi k whole divided by 2 pi k its whole square. 1 2 pi k and this is get cancelled. You get x of k is equal to j divided by 2 pi k. This is the final answer. This answer holds good only when k is not equal to 0. K is not equal to 0. What happens when k is equal to 0? When k is equal to 0, that is x of k is equal to 1 by 1 integral of 0 to 1. X of t value is 1, e to the power of minus j 2 k its value is x of t value is t, e to the power of minus j k value is t. When k is 0, e to the power of minus j 2 pi k into t into dt. When k is 0, it will be integral of 0 to 1 t its value into dt. That is t square by 2. Substitute the lower and upper limit. Answer here it is x of 0 is equal to 1 by 2. This is when k is equal to 0. This is when k is equal to 0. That means we have two answers here. When k is equal to 0, x of 0 value is 1 by 2. When k is not equal to 0, you have j divided by 2 pi k. Okay. Now, you can get its magnitude and phase spectrum. That is, first I'll write x of k is equal to j divided by 2 pi k when k is not equal to 0 and its value is 1 by 2 when k is equal to 0. Okay, what is the magnitude of this? That is, magnitude of this is x of k is equal to, when k is not equal to 0, it will be, magnitude of this is 1 divided by 2 pi k. Because real part is 0, magnitude of this you can calculate it, root of a square plus b square. Real part is 0, imaginary part is 1 divided by 2 pi k, and so you'll get its magnitude. Then what is the angle now? Angle of this is, or phase part is, when k is 0, there is no imaginary part, that's why, and that is, its value is 0. When k is not equal to 0, imaginary part is there, but real part is not there, and so it becomes infinity. That is, infinity you will get tan infinity, that is when theta is equal to pi by 2. That's why it is pi by 2 when k is greater than 0, and its value is minus pi by 2 when k is less than 0. And theta is 0 when k is equal, that is, angle is, phase part is 0 when k is equal to 0. Okay, now let us plot this phase spectrum and magnitude spectrum. This is the magnitude spectrum. Okay, that is, when k is equal to 0, its value is 1 by 2. Okay, this is the magnitude of k. Next, when k is equal to 1, it will be 1 divided by 2 pi. When k is equal to 2, it will be 1 divided by 4 pi. K is equal to 3, it will be 1 divided by 6 pi. It goes like that. Similarly here also, k is minus 1, k is minus 2, k is minus 3, k is equal to 1, 2, 3. This is 1 by 2 pi. This is 1 by 4 pi. This is 1 by 6 pi. This is also 1 by 2 pi, 1 by 4 pi, and 1 by 6 pi. This you should calculate using the root of, magnitude for root of real part square plus imaginary part square. Here only real part square is there, imaginary part square is not there. Its magnitude is 1 divided by 2 pi k. When k is 0, this is 1 by 2 you have here. When k is 1, 1 by 2 pi. When k is 2, 1 by 2 pi into 2 is 4 pi. When k is 3, 1 divided by 2 pi into 3 is 1 by 6 pi. It goes like this. This is the key. Now it looks like this. Okay. This is the magnitude spectrum. Then what is the phase spectrum? The phase spectrum here is, it's very clear. When k is greater than 0, it is pi by 2. How do you get this one? Tan, there is no real part, that is tan inverse of b by a. B is the imaginary part and a is the real part. Here real part is 0, that's why it will become tan inverse of infinity. Okay, tan inverse of infinity, that is, infinity you will get only when theta is pi by 2. That's why tan inverse of, when tan pi by 2, you will get infinity. Again, depends upon, if k is positive, it will be plus pi by 2. When k is negative, it will be minus pi by 2. At 0, its value is 0. When k is positive, it will be, all answers are pi by 2. This is, k is 1, 2, 3. This is minus 1, this is minus 2, this is minus pi by 2, this is plus pi by 2, this is the angle of x of k. Okay, this completes the problem. Thank you. I kindly request you to subscribe in my channel.